This time cycle in this video we are looking at bivariate data. So data relating to pairs of variables are called bivariate data, and if they are statistically related they can be described as correlated. So here we have some different correlations. Now we have this first one here, and we can see that this is clearly positively correlated. Now that is because as this increases, as the x-axis increases, so does the y-axis. So therefore, we can put here positive correlation. Now this next one we can see has no correlation. Now this may just because the two things are not linked, or there may just not be a correlation at all, which may be unlikely, but it just shows that there is no correlation because it's all over the place. We cannot say it's positive, we cannot say it's negative, because there is no correlation. So I can write there no correlation. And then for the final one, as you probably guessed, it's going down the way there. There is clearly a negative correlation. So as one increases, the other one decreases. So there are two types of correlation though, which you do need to learn about. One of them is causal correlation, and this is when a change in one variable does affect the other one. So for example, you could have something like the temperature and the number of ice creams sold. That would probably be a causal correlation, as you would expect the higher the temperature, the more ice cream sold, and therefore there would be a correlation. If there was a correlation, there would be that a change in one variable does affect the other one. However, a spurious correlation is when there isn't a causal correlation. So in other words, that could be when there is a positive correlation, and it does show this positive correlation, but there is nothing which links the two variables. So that may just be a coincidence. So it could be something like annual income and weight, or annual income and height. There could potentially be a positive correlation between them. However, this would be spurious because the change in one variable doesn't actually affect the other one. So here we have a question linking to a scatter graph. It says that a football coach measured the heights and weights of 12 players, and the data is shown below. So let's draw a scatter graph for this information. So in order to do this, all we have to do is look at the height. So for example, for the first one we have 188, that's around there, and we have a weight of 70, so we just plot our point. So then 194, and then 100, 178, and 83, then 175, 69, then 185 and 77, 175, 58, then 188 and 90, which is up here, and hopefully we're starting to see a correlation in this, and 193 and 86, and then 180, 71, 190, 94, 181, 68, and then finally 169 and 61, just there. So we can see there is a correlation. It looks positive. And if you were to draw a line best fit somewhere like that, it would be around positive. Obviously, do it with a ruler. But then next question is asking us to give an interpretation of a correlation between the height and weight of footballers. So this is asking for a correlation, and in order to this, we would say that there is a positive correlation between the height and weight of footballers. And that is all you have to do. That's why it's an interpretation, because it's quite a wordy question. The next one again is asking for an interpretation, and this time the is asking for an interpretation of the gradient of this regression line. And the regression line is W is equal to 1.37h minus 173. So as it's the gradient, we're specifically looking at as 1.37h, and that means that for every centimeter that the height increases, the weight will increase by 1.37 kilograms. And that is what that's saying by an interpretation. Then for D, we have something a little bit more mathsy. And it says, use the equation of a regression line to estimate the weight of a player who is 170 centimeters tall. So therefore, weight is going to be equal to 1.37. That's going to be times by h. In this particular case, it's 170. And then we'll be minusing 173. So the weight is equal to 59.9 kg. Then in the final question, it says comment on the reliability of your estimate in part D, giving a reason for your answer. So for this question, we have to look at something called extrapolation or interpolation. And interpolation is when it's in the values. So for example, interpolation, if someone was 180 centimeters, is in the values, we have values which show this. However, if we had someone who was 200 centimeters, for example, that would be outside of it. We do not have a value of it. That would be extrapolation. Now, interpolation is a lot more reliable because we have data to show. And if you are extrapolating something, the trends may not continue. So for example, if you had someone who was 210 centimeters, they might not actually have that much of a larger weight because it may be harder to grow into that body, for example. So that could be a reason why extrapolating would not work in this case. There are other better examples though, for example, so you could do bacteria or something in biology where extrapolating wouldn't always work. So for this question though, as it's 170 centimeters, you could confirm that this is fairly reliable because it is within the range So therefore, interpolation rather than extrapolation. So that is the idea of interpolation being more reliable than extrapolation. So thank you for watching this video and see you soon. Bye.